Okay, so let's see what we have in the second question here. So they give you the enthalpy change of formation of HCl and HI are this and this, and they say which statement is the most important in explaining these difference, okay? And they give you chlorine is more negative than iodine, so you can actually remove option A because the electronegativity doesn't correlate anything to the enthalpy chain of formation. And let's consider the left three options here. So if you already forget, then let me remind you. Okay, so enthalpy chain of formation of HCl will be written from its constituent element, which is hydrogens and chlorides that go to HCl. And that is for 1 mole of HCl. So I have to balance out using a half and a half here. And this process is the delta 8F formations of HCl. You can write the same thing for iodine. Okay, so in B, they say the activation energy for H2 and Cl2 reaction is much less than that for H2 and iodide 2 reaction. Okay, so this one I think would be wrong because so if you write out your energy diagram, okay, the first reactions they give you the delta HF of HCl, it is a negative number here, and this is a for HI this is a positive number. So which means the first reaction must be exothermic. So I have to grind the reactants higher than the product. Okay, so HI and Cl will be here and HCl will be here. So this will be my activation energy for this process. I will do the same thing with HI, but the delta HF of HI is the positive number, which means my product will be higher than my reactant. Okay, so it looks something like this, and this is HI, this is hydrogens and iodine, and this is HI. And the activation energy in this case will be this. Okay, and they say the activation for HI and chloride is much less. Okay, so in this case, we can see that the activation for hydrogens and chloride, which is this small part, this small distance is actually less than that of iodide and hydrogens. But I can actually manipulate this diagram so that it could be reversed. So for example, I can draw the activation energy for hydrogens and chlorine here much higher. Okay, so here, I can draw it much higher like this. So now the new activation energy would be this blue distance, okay? And now you can see that actually it looks longer, bigger than the activation energy for hydrogens and iodide. So this option is not accurate at all. So the first two options are wrong. So let's see C and D, okay? So in C and D, they say the bond energy of iodide is smaller than the bond energy of HCl, so you have to remember what is the bond energy, okay? So bond energy is the amount of energy needed to break a specific covalent bond. So this is the energy associated with the bond breaking process. So where does the bond breaking process happen here? Okay, so for H2 and Cl2 that go to HCl, and on the other side we have H2 and iodine that go to HI. A half, and a half here. Okay, so the first process in each reaction is the bond breaking process. So that means for HCl, I have to break hydrogen bond and I have to break Cl bond. For the HI, I have to break the hydrogen bond and iodide bond. And for bond formation process, which is the process that next to the bond breaking process here, I form the HCl bond. On this side, I form the HI bond. And remember, the bond breaking process will take in energy, so this process will be positive. And the bond formation process will give out energy, so it will be negative. But because the bond formation of HCl is negative, okay? So, which means that if I total these two numbers, it must give me a negative number. So, which means that the bond formation of HCl actually give out a lot of energy, much more than the energies that was taken in by the bond breaking process. But for the HI, if I total these two processes, it will give me a positive number, as the questions say it. Okay, so which means that the bond breaking process for HI actually take in a lot more energy. But if you compare the bond breaking process here, okay, hydrogen bond has to be broken in both reactions, but there will be difference between the bond breaking of Cl and iodine, okay? So, because the bond breaking process for iodine will take in much more energy, so the iodine bond actually will be harder to break, okay? And if you look at the bond formation here, the bond formation when you form the HCl will give out a lot more energy than that of HI, which means this one will be more stable, okay? It won't have more bond energy. So using that knowledge, now if you look at C and D, it say the bond formation of HI is smaller than the bond formation of HCl. So actually it's correct because we just mentioned that the bond energy of HCl will be more than that of HI. So when you form this bond, it will release more energies than when you form the HI bond, okay? But option D is that the bond energy of iodine is smaller than that of Cl2. So actually it's wrong because we just conclude that the iodine will be harder to break bonds because it has more energy. So D actually contrasts what we just say. So D is wrong. So the final correct answer, it must be C.